Hi, in this video we're going to talk about limits involving infinity, and we've touched on that a little bit before, but we're going to finally get to actually talking about the formal definition. So in this first video though, we're really going to talk about the notation and really just the ideas. The next video has the formal definition and some theorems and details. Alright, so here you see on the screen a graph of a function with some dashed lines, and you have seen functions like this in algebra, pre-calculus, whatever math classes you took before calculus, so you've seen those before. And you should understand, we've reviewed a little bit this semester in fact, that those dashed lines on the graph represent asymptotes. But sometimes students have a little bit of misunderstanding about exactly what those asymptotes are. So I just want to talk about that a little bit, kind of what you should understand from prior classes, and then we'll connect that to what we're going to be doing today. All right, so really what asymptotes are that they are guides for a graph. They're not actually points on a graph, but they're really guides for where the function is headed as the function heads towards the edges of the graph. And so what do we mean by edges? Well, on this function, there are really several places that we're talking about. We're talking about as the function goes as far as it can to the left and as far as it can to the right. The other place where on this function we might be talking about edges of the graph are as we go up and as we go down. And so there are a few places here where we're headed up and then also where we're headed down. The idea here is that those are there to indicate that that graph is going to get close to that value. It may or may not actually equal that value where that asymptote is, but the graph gets closer to that as we go toward the edges of the graph. The other thing that I want to point out too is that this graph has lines for asymptotes. You actually can have dashed curves that are asymptotes for a graph as well, so they're not always lines. Sometimes you might have curves. But the idea here is that that's where we're headed as the graph gets larger and larger and larger, either in the x direction or the y direction. So the idea here is that x is approaching infinity or negative infinity, or y is approaching infinity or negative infinity. So asymptotes are really about limits involving infinity. So that's why we're talking about them here. One other thing I might want to mention about this graph, so in particular, this place that's just a little bit right of x equals 2 here, you might notice that there the function curve is not really as close to that asymptote as it is on some other parts of the graph. And so I just want to kind of talk about interpretation of that. Unless you see something that indicates that the graph stops or that the graph has some different asymptote, you would assume that because there's an asymptote there and because there's an arrow there, that that would indicate that that graph does continue to approach that asymptote when we go off the graph. It's just that the window we're looking at the graph in, it doesn't get as close as it gets on some of the other asymptotes there. One other thing I want to point out about this graph too is that this particular one, sometimes students get the misunderstanding that a function cannot cross an asymptote. It actually can, and so that's part of why I put this particular function here. But kind of over on the left side of the graph there, you might notice that that function curve appears to cross through that asymptote. But the graph here with the asymptote would indicate that when we go further and further to the left, that function is approaching that asymptote, but really coming up to that asymptote from below on that side of the graph. All right, so we talked a little bit about these asymptotes involving ideas like infinity, and so just to clarify, making sure everybody's understanding what are we talking about when we talk about infinity. Infinity is not a number. It is a symbol that is used to represent the idea of something that is getting larger and larger without bound. And so when we say without bound, what we mean is that there is no highest value for what that thing could be. So however big of a number you think about, that thing is always going to get bigger and bigger than that. And so that describes positive infinity. Negative infinity would be the same idea, larger in size without bound, but in the negative direction. Okay, so again, without really looking at the formal definition, we are going to just look at this graph here and answer some questions about some specific function values and limit values for this function, just using kind of the intuitive sense of limits that we've already talked about before. Okay, so on these questions down here below, this very first one asks us to think about the limit as x is approaching -3 from the left. So I'm going to go on the graph of my function a little bit left of x equals -3 and see where that graph is headed. And we see right there that that graph is headed up without bound. So we would say that that limit is positive infinity or just infinity. You can put the plus sign there or not. Either way, it means the same thing. All right, and then the limit as x approaches -3 from the right, it's asking us that. So I'm going to go on the graph of the function a little bit right of x equals -3 and then get closer to -3 and see where that graph heads. And that one is headed down without bound. So we would say that that limit is equal to -infinity. Notice that does not mean the function output is ever infinity or -infinity. That's not possible that the function would output that value. But this is telling us where the graph is headed as we get closer and closer to -3 from both the left and the right. All right, and then the last one here, as x approaches -3. So we've really talked about this from the beginning, even though in our textbook it doesn't introduce it till here. But if I don't have the function going the same place on both sides of -3, then I would say that this limit does not exist because these two limits are not the same. All right, and then the question below that is asking us something different. It's asking us about the function output actually at x equals -3, and I don't see a point on this graph at x equals -3. So I would say that this function output is undefined, or we could also say that that does not exist. You could use either of those to describe that function output there. All right, this next set of questions is asking us about what's happening at and around x equals 2. So that's the other place we have a vertical asymptote on this graph. When I look at the function and when I'm just a little bit left of x equals 2 and I go toward x equals 2, I see that those function outputs are headed up without bound. So I would say that this limit is positive infinity. On this graph, I mentioned before that even though the graph is not as close, because I don't see any other indication on the graph that it stops or has a different asymptote, we're going to assume that that also does what the graph is indicating to us that we see there, that that is approaching that asymptote. So as x approaches 2 from the right, those function outputs are also headed upward without bound. And in this case, those are the same. So we would say that the limit as x approaches 2 from both sides is positive infinity. Again, you can put the plus in front of that if you want, or just write infinity. But actually at x equals 2, there is no output, so we would say that f of 2 is undefined. All right, these other two limits out here are asking us to think about the function as x approaches infinity and x approaches -infinity. So that's asking us what happens when the x values are getting larger and larger without bound in both the positive direction and the negative direction. And we see on this graph here that we appear to have a horizontal asymptote at y equals 1. So both on the right side and on the left side, those y values appear to be approaching positive 1. Notice that you could have a function that has different limits as x approaches infinity and -infinity. If you just think about a function that you know a lot about, like f of x equals e to the x, and think about the graph of that function has a horizontal asymptote on the left side, and so on the left side that function approaches 0, but on the right side, as x goes toward positive infinity, that function approaches positive infinity for the y values. So for a function like that, you might not have the same behavior on both sides. This one happens to have the same end behavior on both sides of the graph. All right, in the next video, we're going to look at some theorems and definitions and some more examples.